Power to the truth. This is Margo. This is Sunday, December 2nd, 2018. And first of all, I hope that everyone is safe and doing well today, especially the people that have been in the earthquake zones. We had the Alaska 7.0 earthquake a couple of days ago on the 30th. I reported on that over on my Facebook page, and in the last 24 hours we'd have had 726 earthquakes of all magnitudes worldwide according to the USGS. And when you look at this map, it doesn't look like 726. But when you start blowing it up, you realize that the majority of them are the little earthquakes. And there have been a lot of aftershocks up in Alaska. We've also had, one just went off the map here. Oh, here. This one down here on the Pacific Ridge. 5.4 southwest of Africa. A lot of these earthquakes are pretty shallow. They're all 10 kilometers deep for the majority of them. And I had a dream because I was interested in these. What I found was little tiny earthquakes that are called microquakes that are even negative. They come up, I don't know if I can just find any right off the bat over here. Let me see. Here's one. Here's a negative 0.1 at Beatty, Nevada. So, and that was 8.3 kilometers deep, and that was at 2:30 Pacific time this morning. And here it is. It's actually part of the Nevada test site, or Area 51 and all that is down here in this area. And I found a whole bunch of them. When was it? A couple of weeks ago in Nevada, in the town where I live, there were some of these little negative earthquakes, and I didn't know what they meant because it just seemed to me that if you were measuring a magnitude, it wouldn't be in a negative. And so I even emailed USGS, and they sent me a nice email back and said it had to do with algorithms, the algorithm formula that the earthquakes go through. So it was a little tiny quake that would not be felt by a human, but it's actually a little tiny quake. And some of these earthquakes are caused by explosions. I saw one earlier. Let's see. It's not showing up now. I guess it's off the map. Sometimes you'll see them that are from explosions. So that cause earthquakes. They can be quarry blasts, they can be explosions, it can be all kinds of things. So what I want to show you, I meant to say I had a dream when I was looking at these little tiny earthquakes, and I saw a whole swarm of them down through this red line, the San Andreas fault line here, and then coming down on the east side of the Sierra Nevadas, and in my dream, there's a whole bunch of them up here in Alaska as well. And in my dream, the message I got was that the smaller earthquakes are actually more important than the big ones, because they tear away at the foundation and cause an implosion of the surface. That was the message in my dream. And so here, now this is the 24 hours, so that 7.0 is not on this map, but just in this area you can see all these little orange and red dots are aftershocks. These are all earthquakes. Here's Anchorage, and the earthquake happened over here right on the other side of this little body of water. It was a 7.0. And then there were some large aftershocks, and then all these little tiny quakes, and almost 800 earthquakes around the world in the last 24 hours. And that is really excessive. That's a lot. And this red line is where the plate is, the tectonic plate that goes down there. So, and what I was seeing was a lot of these little earthquakes up here in Alaska. I've been seeing them in swarms, not necessarily centered on Anchorage, but all the way through, like in this line going north of Anchorage. And so since Friday, we've had more earthquakes up here in this northern region. You know, like here's one on the west coast of Alaska at Hope, 3.3. Here's a 3.1 at Shishmaref, Alaska. And then we've had some down here in the Bering Sea. Here's a 4.6 at Tonaga Volcano, Alaska. That one was 45 kilometers deep. That was one of the larger ones. So there's that. Now I want to show you, here's the earthquakes in the last 30 days of 4.5 and higher around the world. And we can see this big yellow circle. That was the 7.0. And then that set off some big ones around. We had a 6.3 in Indonesia yesterday. And so we can see that there's been a lot of activity on these plates because it shook all these other plates and everything just moves. Everything's moving. And my last update was November the 19th. And so there's that. But I don't want to spend a lot of time on earthquakes. Like I said, this is not really my forte. I might get into them a little bit more in the future, but there are lots of people who do earthquakes and have been doing them a lot longer than I have. So I'm going to pull up. I have the snow and ice cover from Climate Reanalyzer. They had not updated their picture yet for today, Sunday, so the last picture they had was Saturday, December the 1st, and so that we can see where the sea ice and snow cover is in the Arctic. And so I'm going to do a little backward slideshow so that you can see what has happened. And my computer has to wake up. it's waking up now so that we can, okay. Here it is back on November the 28th. And so you can see that the ice has just been just gradually coming back a little bit here, a little bit there. It's gotten thicker, and here it was on the 19th, which was my last update, which was almost 2 weeks ago. So if we go back forward from the 19th, you can see that it's coming back here in this area, coming down into the Hudson Bay. In the Baffin Bay, it's coming back, and it's coming up to along the edges of the continents of Russia, and then here's Alaska and Canada, and coming back a little more there, and it's coming out a little bit to the east. And so we can see that this whole area for where the Atlantic is coming in is still pretty much ice-free. This is Iceland, this is Svalbard, and here's Novaya Zemlya. It's starting to get ice on its eastern side, and there's no ice really on the coastline up here in the Kara Sea. And then it's still ice-free on the Bering Strait, and we're pretty good ways where it's coming to the Beaufort. So there's that. Here is the Navy sea ice thickness. The image that the computer image that they have for November the 29th, that's their latest image that they had up, and we can see that it's still quite thin. It's getting darker purple, which means it's getting a little bit thicker, so it's not quite to 1 meter up here on the majority. I would say it's more at between 0.5 meter and 0.75 meters on the majority of the sea ice. And then the blue is about 1 meter, and so we have a little bit like right around the North Pole area, which is in the blue, and then it's going into the 2 meter when it's going into the aqua. So that's right around, mainly around the coastline of Greenland and Canada. So we can see that it's still quite thin and doesn't have a lot of integrity yet. So we'll go back to this GIF. This is the 30-day GIF where it goes back 3 weeks and forward 1 week, so that it shows where they're expecting it to end up by December the 6th. And here it is on December the 6th. What they're expecting is a little bit thicker blue ice coming back along the coast of Siberia here, and just getting thicker. It's going more towards the blue, so not a lot added on the extent in the next few days, but mainly the thickness. So that's what they're expecting. And then what else do I have? Okay, this is a movie that I made for you today from NASA Worldview. This is the Arctic with the sea ice, and I started back from November the 19th through yesterday. And this is the sea ice thickness and concentration, and the snow cover. The snow is what you see, the white on the land, and then this is the thickness, the sea ice and the thickness. And where it's white, it's thicker, and where it's blue, it's not as thick or as concentrated. So we can see it's slowly trying to refreeze, but it's had problems up there. It's definitely had problems because of the warm water coming in from the Arctic and from the Pacific, and it's melting from underneath, and we've had a lot of methane coming up, and there's something weird going on with the ozone too, and I'm going to show you that today, and I'm going to ask for some people to give me feedback on that. So there's that. So I'm going to close that. Now, here we are on Climate Reanalyzer. Let's see if they happen to have today. Okay, they've got the 2-meter temperature anomaly for today, December 2nd, and we can see that over here above, or yeah, right to the north of Alaska, it's really high in the red zone. That's like 20 degrees Celsius warmer than normally. And then the brown, red and brown means it's higher than normally. And here it is, brown in this Arctic Ocean here and here. And this is the temperature of the air, and we can see the United States is brown on the east coast, on the eastern side. So I'm going to click around the globe. We're going to do a global update today, in addition to looking at sea ice. We can see it's brown over Europe, brown over here in Siberia. There's huge methane releases coming up right here in this brown area. You'll see it when we go to cams. And huge red area over here in, yes, I think this is, yes, this is China here, and then this line is where Russia comes in, where Russia and China meet. So that's actually red there, and we're going to see a lot of strange ozone patterns over here. So pay attention to this area as we're looking at it today. And then the southern tip of South America is brown. Antarctica over here near the Weddell Sea is reddish brown, so that's extremely warm. And we can see that southern New Zealand is brown, and a lot of Australia is brown. And I know that they've got a drought going on, and they've got a bunch of wildfires burning in Australia. Now we can look at precipitation and clouds around the world. We can see that the eastern side of the United States is getting dumped on, and the fires over in California have gone out. We did get some rain, and they had flooding and mudslides and stuff after the fires, so it's still raining some over there. had some snow up in the Sierra Nevadas, and so it's good. It's getting colder, which it should be. Looks like a big storm coming into England and Europe, and we've got a lot of rain coming across the Congo, it looks like, and there's something here, yellow. A lot of rain here. Looks like a big storm coming up from the Pacific, and here coming across. That looks like one of those atmospheric rivers here, doesn't it? Look how long that one line of rain goes. The green is rain. Goes almost all the way across the Pacific and over to South America. That's crazy. A lot of rain over South America. And then got some snow happening in the Antarctic. And then looks like rain in New Zealand. And rain in like a little bit of the interior of Australia, but they need a lot more rain than that to take care of those fires. Let's look at the jet stream. And for those of you who are following abrupt climate change, you know that the jet stream does strange things when the temperatures are off in the Arctic, and so they split and they do loops, and they cause strange weather patterns, and they cause it to be cold where it shouldn't be cold and warm where it normally isn't warm, and things like that. So we can see this happening here. We can see it kind of splitting and then going across Africa and then doing a loop over Norway and Sweden and then going down and then back up there, and then a loop here going across India and so forth. So it's some crazy weather all around the planet, definitely. These are very high winds on the jet stream coming across the Pacific. And here it is in the southern hemisphere, split again. Here's one going around the Atlantic and then another one going over Australia. I don't know if that's normal. I'm just showing you the pictures. I really don't know if that's normal. So, no, they don't have the picture for today yet up. Let me refresh this and see. No, it's still for Saturday. Sometimes they're a little bit late getting these pictures up. Usually they get it up within a day, though. Now here's the Antarctic, and it's summertime, or going into summertime down there, and so the sea ice around the continent is melting, and since there's no land mass around that ice, it usually does melt pretty much completely, and I'm going to show you some of that in a moment when we get over to NASA Worldview. Now we're going to go to sea surface temperature anomaly, and this is how much warmer the sea surface temperature is than it normally would be. And this is in degrees centigrade. So this brown to red is 4, and then the red is about 5. So we can see here on the southern part of Greenland, the sea surface temperature is quite warm, and all around Greenland, and then where it's coming in from the Atlantic into the Arctic, it's all quite warm. That's another reason that the sea ice is not coming back in this area as quickly as it normally would, and we're also seeing massive loads of methane coming up from the sea surface here when we go to cams. So pay attention to that. We also have brown in the Pacific on the west side of Canada and up here from Alaska. And almost all the water has some brown in it, meaning that it's warmer than it should be, or warmer than normally. And here in between Japan and Asia, it's brown and red, and then on the other side of Japan, then it's very red here. And then the Pacific, it's more brown than not. And then here's that area where we saw that rain band, that atmospheric river, and so it's warmer than it normally would be. And here's another area that's like a line. South America, around South America, it's brown and red. And look at this, all around New Zealand, the southern part, look how abnormally warm it is around this southern island. It's even into the red zone. So this water is hot. And over to Australia too. And then it's in the brown zone too. So that can cause some really strange weather and strange clouds and different things to happen down there. So there's that. Now we're going to hop over to NASA Worldview. I had the Antarctic pulled up. Let's see if they have images. Okay, we've got images from today, and we can see, okay, this is north, south, east, and west. This tail is the Western Antarctic Peninsula. This is the Ross Sea down here. This is the Ross Ice Shelf, and we can see where the ice has totally melted away from this ice shelf. There's still some sea ice out here, but it's pretty much melted right up to the ice shelf itself. This is, like I said, the Ross Sea. Over here, this is Pine Island Glacier that we've been watching, and this is cloud covered today. So I'm going to go back a couple of days and show you the progress of that iceberg that broke off that I reported on. And here it is. This is the best picture that we have recently. This is from November 29th. Let me see. Okay, there are no clouds here. So this is the actual ice that we're seeing. And that's as close as I can get it. But we can see definite breakage all the way across, and then it comes down and then across, and we can see that it's breaking up into pieces all the way across, coming back even. And this line here was where it had broken off last year, And now, and these pieces are from where it broke off last year. So this is sea ice where it refroze, but this is the part of the ice sheet that has broken off, and it's being held in by sea ice right now. So it's not drifting out into the ocean, but it is breaking up. It's definite. You can see definite lines of it cracking and breaking up, and the black, that is the sea through there. So I would imagine that this sea ice is not real thick, and these little things that look embossed, those are leftover pieces from the iceberg that broke off last year. And this edge is where the Pine Island Glacier, where the ice sheet used to be, and it's been retreating more and more and more each year. And the climatologists are worried about that, because the more the edges of this ice sheet break off, the more it opens up the flow so that it flows out faster. And this does raise the sea level around the world. So there's that. So we can see the ocean here. This is sea ice. This is sea ice that's broken up. This is sea ice. And this is the Thwaite, I think it's the Thwaite ice sheet here. And let's go back to today. It's a little bit cloud covered, but I wanted to show you up here the progress of the Larsen ice sheets ice shelf. And remember, I did my video on Meet the Larsens, and so if you don't know about the Larsen ice shelves, go back. It's a couple of months ago, and it's called Meet the Larsens, the story of a happy ice shelf family that was torn apart by abrupt climate change. And so this was Larsen A that broke apart a long time ago. This was Larsen B. It pretty much disintegrated several years, a few years ago. And then last year, Larsen's, this is the Larsen C ice shelf here. And this big iceberg broke off over here. And I show all of that in my video. Last summer in 2017, during their winter season, it broke off. And then this summer, it started moving around. And so, well, I'm not sure when. But I'm going to show you where it is. It's getting ready to go out to sea. And it's a trillion tons or something like that. It's huge. It's huge. And we can see that the sea ice around it is really getting broken up. It's melting quickly, it looks like. And this is that iceberg. It's called A68. And so it's got a lot of momentum. And where was it? November? Let's go back. I think it was the 4th. I had a good picture of it. November something. Okay, we can... It's been really cloudy down there. Here it is on November the 6th. So, not quite a month ago, we can see that it was more kind of to not as far left counterclockwise But I know that doesn't sound real scientific, but just bear with me. Oh, November 2nd, that's a good one. Okay, that's a good view right there, November 2nd. And now let's go to December 2nd. Look at that. You see the difference? November. Wow. See, it was kind of at a 1 o'clock position here. And now December 2nd, it's like 12 o'clock. That's moved a lot in a month. And look at the space around that sea ice. So it's got a lot of momentum, and if the sea ice is not very thick, it's going to be pushing that sea ice out of the way. There's not much left, and then it's going to be going on a journey. These are interesting clouds. It looks like these are being beamed. Look at these look at these. Those don't look normal to me. Oh, by the way, I hope everyone's enjoying my video that I did a couple of days ago. Oh, look at these clouds. Those definitely, look at these little ripples. That looks like beaming. Either from microwave or HARP or something. But they're definitely doing it. So I hope everyone is enjoying my video that I did a couple of days ago. And if you haven't seen it yet, make sure to see it. It's eye-opening. This stuff is eye-opening. And because we're going to be building on that, it will help you understand about what's going on with the climate and why. Okay, and so we can see the sea ice that's melted up on the northern part. Let me see. Okay, here's the Weddell Sea. This is an ice sheet here. It looks like there's cloud cover there today. Yeah, that's pretty cloud covered. And oh, I was going to show you the sea ice has broken off from the ice shelf here. Now the ice shelf used to come out along here until that iceberg broke off of it last year, and now that's sea ice. But that line is just to show you where it used to be. And this is from abrupt climate change, from the warming. And then this is Larsen D down here. Oh, down here is Larsen D. So that's kind of in the clouds. We can't see much of that right now. Okay, here it is from yesterday. We can see the ice has cracked all along the edge and is broken away. It's melted. So the sea ice is going to pretty much go away. Let's go over. Well, let's look at this. Then over here on the east side, this is the Amory ice sheet coming down. We can see that this is looking through clouds, but you can see that the sea ice has, here it is. That's a good view from a couple of days ago. The sea ice has broken away from the edge of, pretty much from this whole edge of this ice sheet. So what we'll be able to see now is if this starts flowing out real fast. We'll be watching that, because that's a huge ice sheet there. And what's interesting is these are the rocks here. You can see down to the rocks, and this is ice and snow here. So as things melt more, you'll be able to see the rocks a little bit better here. Then down here is the Totten Glacier and ice sheet. That looks pretty good, and so forth. Now I'm going to take you over to, this is the Navy website. I'm going to take you to Antarctica, and let's just look at the thickness of this ice. This is for today, and we can see it's not very thick. In fact, well, the thickest part is over here, near the Antarctic Peninsula. Maybe that they're counting that. I don't know if they're counting the ice shelves. I wouldn't think they would count the ice shelves as sea ice, but maybe they do. Maybe they do, and that's why you're seeing the thicker ice there. But there's not much ice to hold that big iceberg in, that A68. And so it's quite thin. The rest of this is going to melt off pretty quickly over on this eastern side. And there's not much left all around on this eastern side. Let's see the 30-day GIF for the Antarctic. Yeah, it's really going to be thinning out in these next few days. So it's going back 3 weeks. So what you're seeing is back 3 weeks. Let's blow it up a little bit. And then it's going forward 7 days. So this is going to be really melting a lot in the next week or so. So by the time I do my next report, we'll see great diminishment of the ice down here. Now remember, the sun is up all the time down there now. And December, I think it's the 22nd, they'll have their summer solstice when we have our winter solstice, when it will be, the sun will be at the highest down there, and so it should be the hottest down there, and then it'll start going back down. But it looks like the thickest ice was over here on this west side. There was some red ice, and that will be gone. Looks like the red ice will be gone by the 9th. So a week from now, the red ice will be gone. That was about 4.5 feet thick, looks like. So there's that. And I wanted to show you, this is from Zach Laib's Twitter page. This is a tweet that he put out yesterday. And this is, he's a student of climatology, and this was from yesterday. Arctic sea ice extent is more than 700 50,000 square kilometers below average. And here we are in 2018, this aqua line, and we can see it was at the bottom. It's been at the bottom all the way through these months, starting from January. This is for the sea ice extent. And then it says, now let's move forward. The Antarctic sea ice extent is more than 850,000 square kilometers below average. And he says neither are record highs. Certain blogs and articles are misleading. This is true. And so we can see, here it is, 2018 is the aqua, and it's pretty much at the bottom for this time this year. This is the Antarctic sea ice extent. Remember, extent is not concentration. There's a difference. Okay, so there's that part that I wanted to show you. Now, I want to just review this map with you from my last show that I did. This is from the paper on 50 years after the wrecking of the environment. It was quite eye-opening. And this map, it shows the relationship between major petroleum and natural gas production wells and the boundary of the Siberian traps that are indicated by the black line, and the red dots are methane hydrate deposits currently locked into the permafrost, and the purple are the oil giants. And saying that within this extensive area upon melting pose a major catastrophe. So this is Russia, this is Siberia, this is Novaya Zemlya, and so I want you to look at this, just refresh this in your memory, and now we're going to go over to CAMS. And I've got methane pulled up, and the data that we have is Wednesday, Thursday, Friday for this week. And this is the North Pole view, and we can see that starting on Wednesday, this is very, very disturbing, because we're seeing this black right up here inside, well, all the way through Siberia really, but especially on this sea coast and coming up in the Arctic Ocean, and then it's red, and then we see it even red up here by the North Pole. So, I mean, it's just disturbing to see these high methane levels worldwide, much less up here where these high deposits are. So I already have this movie loaded up. It might have to reload. So you can see it as it's reloading, that it looks like a big red dragon coming up out of the sea. And I posted this on my Facebook page, and if people want to follow me on Facebook, I post things, you know, in between videos. I'm posting something almost every day, and I'm Margo on Facebook. So we've got high methane releases. This is at surface level. High methane releases. And the chart down here, this is in parts per billion. The orange is 1980 parts per billion. The red-orange is 2000. Then the red is 2020. The darker red is 2040, and the black is 75,600. So we can see India covered up, China and Asia covered up. We can see it's even coming up out of the Indian Ocean here. It's coming up out of the water. This is water over here. This is Saudi Arabia. This is all of, the European countries. And then northern Russia and Siberia, and of course, United States, West Coast. And I don't even have a whole world view up here. This is just the North Pole view, so you can see basically the northern hemisphere. And the northern hemisphere is in this higher green level. The majority of it is in this higher green level from 1860 or 1880 to 1900 parts per billion and higher, and then the southern hemisphere is a little bit lower. But it's winter time, and this is coming up through the ice. It's coming up. Now there is ice here. Here's the North Pole, so there is ice here where it's coming up there. There is not ice over here, but there is ice coming that we saw that's come back on this eastern side of Novaya Zemlya, but there's not ice up here, so it's just coming up. I think we're having an event. And this is from Wednesday, Thursday, Friday, and then Saturday and Sunday are in the forecast period. So I think we're having an event. And if we have an event, no one's going to tell us about it. We have to be watching these charts and maps and things ourselves and be witnessing for ourselves. And if you see something, wow, look how black the U.S. gets. It's like the whole country just turns black. So if you see something, you need to screenshot it or make a video of it and get it posted, because it could go away. Could definitely go away. So there's that. Now I have sulfur dioxide pulled up on cams. This is the Pacific view, and we have data back from Wednesday through today, and I already have this loaded up, and this is in parts per million. And usually when you see red sulfur dioxide is from geologic activity like earthquakes or volcanoes, but we're seeing the red over here from China over highly populated and industrialized areas. And you can see here that there was sulfur dioxide being released from Alaska before the earthquake happened. It was red, and they are having a lot of a lot of volcanic activity going off there too. They have like 100 volcanoes in this Aleutian Island chain down here. It is highly active geologically. Then we have this going off in Mexico all the time. I don't know why nobody is reporting on this, but that's high sulfur dioxide levels. I mean, like Hawaii with the volcano that's been going off since May there. And then we've had some volcanic activity and a lot of earthquake activity down here in South America. Then lots of earthquakes on this Pacific Ring of Fire is what we saw, and volcanoes going off too. So there's that. I just wanted to show you this. Then I'm going to spend the rest of the time looking at ozone, and I'm going to start out with the South Pole view. And last time we saw the ozone hole was still pretty big over the South Pole, and but since then it's closed up quite a bit now that the sun is up. And remember that this is okay. This is total column ozone, and this is measured in Dobson units. And once you get into the yellow, that's 300. Yellow, gold, and red, and above. And they say average is 300 Dobson units, and that's equivalent to 3 millimeters of ozone through the atmosphere. And that's what protects us from UV radiation from the sun and cosmic rays and different things. But once you start getting down into the green, those are the lower levels, and so the ozone is thinner. And like the aqua is 220 Dobson units. This purplish color is 200 Dobson units. So the lowest I see here is in the 200 today, and it's not very much. And the data goes through today. It runs from Wednesday through today. So with the sun up down there, it's the ozone layer is being able to come back to thicken back up, which we expect, because ozone, the good ozone, is created by sunlight interacting with oxygen, and it turns the O2 into O3. That's my simplified way of explaining it. So that's looking better on the South Pole. But there's some other stuff that's going on. Here's the world view for the ozone. Let's run this movie. This is from Wednesday through today. Now we can see that it's still thin around the mid-latitudes. It's thicker in the southern hemisphere, which we would expect, since the Earth is the southern part of the globe is tilted towards the sun. But what I'm seeing in the northern hemisphere doesn't make sense to me. I'm seeing this red and black and, you know, all the stuff up here in the northern hemisphere, which I've never seen this before, and I don't think this is normal, especially for this time of year. I'm thinking that it should be getting thinner up here in the northern hemisphere, and especially in the Arctic. So if anybody knows about this, and it's like, it just doesn't make any sense to me. because where it's colder and there's less sun, it shouldn't be thick ozone being produced through the columns. But what we're seeing, okay, let me pull up. Okay, here's the North Pole view. And to orient yourself, okay, so now we're basically seeing the northern hemisphere. Here's the North Pole, here's Greenland, and here's the Atlantic Ocean, here's the Pacific, and then this is all the Pacific, and then this is Russia, and here's Alaska. So let's run this movie and we'll see exactly where it's coming up. It's coming up here in Russia, Siberia, and over here in the sea. It's basically, this is water area over here. And then over from Mongolia, this is Mongolia here. So I don't know if this is bad ozone that's just going in column-wise, or if it's from other pollutants causing this or what, but it's kind of disturbing to me. And it just doesn't make sense because first of all, there's no sunlight here in the Arctic. There's no sunlight at all, and so we should be getting a thinning of the ozone in the Arctic with no sunlight, but instead it's getting thicker. And it looks like it's coming from this black ozone that's coming from Russia, and then this part of China over here, and this sea. And that sea, I pulled up a map, that is called the Sea of Okhotsk. Okhotsk. Can't say that. And I just don't understand. Here's Japan down here. Here's Kamchatka. And then we've got this sea, and that ozone is coming up out of the sea. And here's NASA World View. Here's the Arctic, and this black area is where there is no sun. And a lot of this area where we're seeing this red ozone, there is no sunlight. So I don't understand. It just doesn't look right to me. So this is coming down to about, not quite the 60° north latitude. It's about at 70. It's at Iceland now, where the darkness is. And a lot of Russia is in the darkness now too. Here's the 60° north latitude. So if we look back over here, where's my movie? Here it's running. This is 70 degrees here. So that's where it's dark. All around there. All around there it's dark. We can see pretty heavy ozone over Alaska too. And then it's thinner over here where from the Atlantic over, and then it gets thinner over here into the green and into the aqua, and that looks more normal and like what it should be doing. But it should be thinning up here on the North Pole, because that's in the dark and that's where it's coldest, and that's where the ozone would be thinnest. So I'm kind of freaking out here, or flipping out, not freaking out. And I've got another, this is a closer up view. This is the Arctic. And I'll show you exactly what I'm talking about. Now see, it's thinner where the green is up in Canada. We would expect that. We expect it to be becoming green and aqua, and more of this aqua color as it gets thinner, but definitely more into the green. But instead it's red. And it did not look like that in the South Pole during the summer when we were looking at ozone, or during their winter. It did not look like this. So, you know, this is my first year to be reporting on all of this and to be looking at it. So, I just don't think this is normal. And it looks disturbing to me. And then I'm going to show you carbon dioxide, and we'll close this off. This is worldwide carbon dioxide. We have data back Wednesday, Thursday, Friday. And then it goes into the forecast zone for Saturday and Sunday. And we can see that it's higher. The higher levels, the more north you go, except for like Africa here. It's high in South America. And of course, it's high in North America, where we have industrial civilization, burning things, burning fossil fuels and things. And it's very high over here in China. And then that goes up to the North Pole as well. So these levels are about 414 parts per million up to, for this one, this dark brown is about 420, and then the top end is 1,000 parts per million, which I don't know if this almost black area over here is in that. It's probably not that high, but I just know that that whole area is high in nitrogen dioxide and particulates and all that stuff too, and methane and all of that. So that's my report for today. This is just to document and to witness and to show the breakdown of our environment as we're moving forward with abrupt climate change. My name is Margo. My website is glc.margoshealingcorner.com. I do believe we are in the end times. We need to get our spiritual houses in order, because none of us know the day or the hour. I am doing life coaching for anyone who needs someone to talk to, just to kind of reframe things. If you're interested in coming from a spiritual perspective and talking about things, I'd love to do some sessions with you. You can find that on my website too. Until next time, God bless everyone. Go in peace. I love you all, and goodbye.